Hi, so today I want to take a look at this Solax X1 EV charger. I wasn't actually intending on making a video about this. I just bought it. This isn't sponsored or anything. I just bought it because I was looking at integrating solar and EV charging so I could optimize the usage of my solar panels. But this is actually one of the cheapest chargers you can get in the UK, 7 kilowatt wall mounted chargers. And I was expecting this to be like a fairly bare bones type of thing, but the reason I thought it was worth doing a video is that I was very impressed, like in terms of the features, the build quality and lots of other things. I think it might be of interest. I think this offers very good value for money, and to be honest, I think I'm struggling to think why you would buy one of the more expensive options out there in the UK. So this was £325 including VAT, which is our sales tax. I think it's now gone up to £350, and I think the untethered version is still £300. So yeah, very much at the low end of the price scale. So let's just take a quick look around what's available in the UK. Screwfix is a very major home improvement type seller. So if you look at what we've got here, Master Plug, which is a sort of generic, I'm not sure if it's Screwfix own brand, but it's a very sort of generic low-end sort of brand name. Untethered charger 314, Sync Energy 449, 359, this is the tethered Master Plug, more Sync Energy 400, 500, EO Mini Pro, they've been around for quite a while, 736, Sync Energy 600 for a tethered charger. These are all sort of very similar looking. So we go to another more specialist electrical distributor. So these are all 7 kilowatt chargers. My Energy Zappy, this is a very popular brand, 617. Ohmi, this is a sort of lowish end, 130 odd. Hypervolt, that's another very popular brand, they've been around for quite a long time, 624. So we're all talking about, you know, the sort of 600 odd quid mark. Let's do a search by price. So if we search by price on here, lowest cost we've got is 309 for EVSE, and then the next one up is the Solax, and basically everything else is more expensive. So in terms of features, obviously it's got all the basic functionality. It's also got sort of Solax cloud integration with solar and everything else, but all the functionality can be used completely standalone without having to go anywhere near the Solax cloud, which I think is a very important thing. There's a local web interface, so you can actually do most of the control and settings without using the Solax app at all. It just appears as a Wi-Fi hotspot you can connect to, and then you have a web interface. There are a few things that you can't configure through that, but for that you can then use the Solax app, but you still don't need to use the cloud. You can do a direct connection to it from the Solax app to do those settings, and those are generally one-off settings that you only need to set once and then forget, and then after that you can just use it standalone if you want to. Now I know it's likely there'll be some viewers looking at this video who aren't part of my normal highly technical subscriber base. I'm just going to start off going over general features that are of interest to anyone sort of looking for an EV charger, and then we'll take it apart, see what's inside, and then get onto some more technical stuff, test some of the features and see how it works. So the overall format is a very traditional wall-mounted unit. This is the tethered version with the built-in cable, and there's a sort of socket on the side. On the untethered version, this will be your socket, but on the tethered version, this just can be used as a place just to park the cable. One unusual feature I'm not sure I've ever seen on any domestic charger, it's actually got an emergency stop button. Now obviously there could be situations where this is a disadvantage, people messing around with it. There isn't, as far as I can tell, any way to actually disable that functionality, but yeah, if it was something that was of concern, you could always just 3D print a cover or something over that, so I don't think that's a big deal, but it's not a feature I think I've ever seen outside of more commercially orientated products. On the front you've got like a vertical line indicator that can change colour depending on what it's doing. There's also an RFID card reader built in, which again is not something you often see on the lowest end devices, so this just allows authentication to enable the charging, and that's something you configure. It comes with two cards. In the app there is the option to administer these cards, so these are the two that came with it, so these seem to already be programmed in, but you can go ahead and again you can either scan the barcode, enter the number manually, or do it through the charger. Not actually seeing how you can delete these cards unless adding a new one replaces one. The card numbers do get logged in the information, so if you go on the app and look at the history, it will tell you which card activated a particular charge session. Now the mounting of this is a separate backplate which has all the connections on it, so the whole thing can be removed. There's 4 screws that go in the side. There is also a locking kit they provide if you want to. You can install this and then you can padlock it, so you need to remove that lock before you can remove it from the wall. And obviously this has some advantage for installation, particularly, for example, if you ever need to replace it or return it for repair. It's something that the end user can do. Literally, if you're an electrician, you've installed this for a client, they've then got a warranty issue. Instead of you having to come out and charge the client to deinstall it and dewire it, which is the case for quite a lot of other chargers on the market, literally all you need to do is take those 4 screws out, pull it off the wall, and you get some fairly safe shrouded contacts. Obviously, you tell them to switch off the power, but even with the power on, you'd have to actually stick something in here for that to be any hazard, and then the unit could be returned, repaired, dealt with, which is quite a nice feature. I don't know whether Solax currently offer this, but it's something they could potentially offer, is a situation where, for example, if you're fitting out a block of apartments, you could potentially just fit all the wall plates with a blanking plate over the front and then fit the charger later as required, and that's certainly something that's possible. The connections, that comes with 2 cable glands, one for the power and one for the various interconnect options, and they actually supply a multi-entry cable gland with this. So there's actually 4 plugged entries on this. So you can just take out however many you need, up to 3 cables that you might want to connect to this. And the entries in the insert are actually pre-cut, so you can actually take a ready terminated Cat5 cable, feed it through over the cable, so you don't have to dick about terminating your own Cat5s inside the unit. You can just feed the ready terminated cable through. Genius. It's also possible to do a rear entry situation. There's a couple of drill out the centre mark, they're not really knockouts, you'd have to drill these out on the rear, and then this comes out, so you have your connections here. This is the single phase, obviously the 3 phase has got another 2 pins on here, and this basically connects the sockets on the back of the unit, and you can plug connectors in directly in the back if you wanted to. This actually snaps out, it's just an extra piece, so if you wanted to, you could use these connections on the back if that suits your install better. So coming through the back, it would be probably a little bit tight. I think you struggle to get a cable gland on here, but if you could ensure the sealing, then I think that would be a fairly reasonable option. And in fact, in terms of sealing, even with a rear cable entry, even if that wasn't totally sealed, this is outside the body of the charger, and obviously any water that did come here would go downwards. So it would take quite a lot for anything here to get damp. So I don't think that's the major issue if you went for the rear entry. Right, these connections in the back, the first one has 2 functions. One is a wired LAN connection, so this has both Wi-Fi and hardwired Ethernet, which can be useful. Quite a lot of the lower end chargers don't have that hardwired LAN connection. That could be useful obviously if the charger is located away from the house, out of range of Wi-Fi. You might need to run a Cat5 cable back to the house. Also, it means you could connect it, for example, to a local power line Ethernet adapter easily. There's another couple of functions on this connector, which is to do with, I think, regulations in Germany, where to control grid loading, there's 2 external contact closure inputs. One will reduce the charge rate to 4 kilowatts, and the other one will temporarily suspend charging, so they can control the use of chargers externally via the grid. That's something that could also be used, generally useful if you just want to have some way of manually controlling or manually turning it on and off. If you did want to use both of those connections, they actually give you a 2-to-1 adapter for that to do that, which is nice. The middle one, this is RS485 Modbus. This charger does support OCPP protocol for remote control. I'm not that familiar with the details of what that allows you to do, but as far as I can tell, that's all supported. And the other connection is for a current transformer. This is so that if you need to control the total load on your grid, let's say, for example, you've only got, say, a 60 amp mains incoming grid connection, you can use a current transformer so that this will adjust the car's charge rate to make sure that the total load of this and whatever the house is drawing is below that limit, and they actually give you the current transformer included in the package. It's not an optional extra, which it is on certain other products. And obviously this only comes with a relatively short cable. You'd need to extend this, but again, they give you a back-to-back coupler, so you could just extend that with a standard network cable, which is quite nice, and include 4 RJ45 plugs. On the back of the unit, you can see these are all the connectors. So this is a single phase, but it's actually got all the phases, and there's this nice sort of soft squishy seal that engages with this wall in the rear cover, so this becomes a completely sealed enclosure with all the electrical connections inside it. And obviously the charger itself is a sealed unit. So there are some chargers where you're relying on the installer to make sure that their incoming cable gland is properly sealed to the actual whole charger. If it isn't installed properly, then that could obviously cause problems. So yeah, looks like this has been very well thought out. Let's just take a quick look at what we can do with this before we even go anywhere near the app. It provides a wireless access point. You can then connect to, you then go to a specific IP address and enter username and password. Password's printed on a sticker on the side, but it's also the same as the access point name, which is possibly not ideal. But I think, if you're concerned about that, you can I'm sure you can either change it or disable the wireless access point completely, so I don't think it's a big deal. But also that information, as far as I can tell, it's only on a sticker on the side of the box. I don't think there's a card or anything on the back of the unit itself inside the back plate. So if that sticker gets damaged, then the fact that the password's the same as the access point name at least means you can actually get in there. Okay, so once we're into here, the font size is rather small. On a phone, it's actually very difficult to read without zooming in quite significantly. But you've got some basic device settings. So this is normal, OCPP or solar, and the solar, I'm not sure exactly how that integrates yet. That's something I've not yet investigated. And then the activation mode is plug and charge. Obviously, you just plug the current and it starts charging. RFID, you need the RFID card to start the charge. So you plug in, you then swipe the card, and it then starts charging. And then app requires the app to enable the charge. Earth type, this is to do with the pen fault protection, which is a requirement for UK installations. I'll probably go into the technical details of that a bit later on. And RS485, this is for Modbus address and baud rate. And there's configuration here for OCPP. I don't know anything about that, but looks like you've got a server address and a charger ID in here. Then on network, you can enter your credentials if you wanted to connect to your local Wi-Fi network. Options in here to do various resets, reset factory settings, and also do firmware updates. There's also a log which produces quite a lot of fairly technical information, which again is not likely to be of any use to normal users, but people like me find this stuff interesting, so you might be able to extract information from there. It does look like the Modbus protocol is fully documented. There's a manual on the Solax website that seems to have sort of, I don't know anything about Modbus on this thing, but it seems to be fairly comprehensive. There's all various register definitions, command formats, etc. So that looks all good. And obviously the settings for time and date. There are a number of other settings that you can't change from here. You actually have to do via the app, but you can still do that using a local connection. It would be nice if they updated this to allow access to all the settings through this interface, but going through the app is not a huge deal. So looking at the app, when you install it, you get this sort of invite to log in and or set up an account on Solax Cloud, but you don't need to do that. You go up to more, we can then do local access, and we can then just scan the code that's on the side or type in the number. So we're now logged into the device. We've got access to what it's currently doing, whether it's charging, what the charge rate is. We can go and set things like our charge current. We do charge scheduling, and again, this is all stored within the unit. You don't need the app for this to work. And there's various stuff that you can access. You can actually show the current, main voltage. This is the charge current, but also if you've got the current transformer set measuring your grid connection, you can actually access the current that's being measured by that current transformer, and it'll actually tell you the temperature. And now we can go into settings. So this is where we can get access to a few more settings than we could through the web interface. Charger setting. Again, we've got the mode select. We can set the brightness of the front panel LED. So these are currently set to full brightness, so we can, if that's too bright, we can just turn that down. And that's now dimmed it down. We can set the grid loading, so this works in conjunction with the current transformer to set how much we're allowed to take from the grid. With the current transformer, then the entire power from the house and the charger wouldn't exceed that amount, and it will reduce the charge current accordingly if necessary to keep that below that figure. And we've got the same Modbus settings we had in the web interface. In here we've also got a load of advanced settings. So we've got the setting for, again, solar standard and OCPP. Parallel setting, this allows you to have multiple chargers on one connection. I think it will do the grid balancing between all of them and the solar integration between all of them. Random charging delay, this is a requirement of the UK smart charger regulation, so that if you've got scheduled charging, it can randomise it so you don't get loads of chargers all coming on at exactly the same time, which can cause grid problems. As well as schedule, you can actually tell it not to charge within certain time schedules, which might be handy perhaps if you want to avoid times when the electricity is more expensive, or when you've got other heavy loads going regularly. And so we've got some alarm settings for over voltage and low voltage. and factory settings, and reset on there. So there's just one or two small settings, and again, it's the sort of thing that you probably set once and forget that you need to use the app for. And you can also just start and stop charging from here as well. And if you do want to go into the app, this will then integrate with all your other Solax devices, and the other main information you get is usage. So this has got all your usage data, so it will show, obviously I've been testing this, so it's not actually charged anything, it will just started and stopped a few sessions. But for example, it will show the ID of the RFID card that was used if RFID was enabled. And again, you've got all the settings that you can do remotely. Obviously, the other thing is, in this mode, you can access this remotely away from your own network. You just need to log into the Solax cloud. So, and that sort of covers really the basics. It seems to have pretty much all the features you'd need. Even if all you want is just the basic bog standard charger, it's still one of the cheapest out there. It does everything you need it to do. The internal build quality is very good. We're going to go into that in a bit later. I've already had a quick look inside, and everything looks well built. There's no corners cut. So I think this is really exceptional value for money, certainly compared to some of the others out there. Unless you need some very specific feature that some of those other chargers provide, sort of prefer the aesthetic look of those, then I think this would just be a very good default charger, unless you need something more special to go for. So the wall mounting is via 4 hex screws that go sort of through the side into these metal bushes. Slightly annoying that they don't give you the Allen key for that, but obviously Allen keys aren't a big deal to get hold of. But there's 2 screws in the back here that remove the front fascia. This is just a cosmetic fascia, and in principle maybe they're going to do alternate colours or replacements. Obviously, if there's any mechanical damage, that's an easily replaceable part if they'll supply the parts. I suppose if you wanted to, you could even take that off and paint it. Then there's 10 screws that hold the actual front panel onto the case. These are self-tapping, but they're stainless, so they shouldn't get any rust issues. One of the first things I noticed, which was amongst several little details that really, aren't necessary, but they've added, it looks like they definitely weren't thinking about sort of minimising cost, is this little switch, which engages with this bracket on the front panel, and if that gets released when it's powered up, it goes into alarm mode. That just seems like a sort of slightly bizarre function, because they've gone to the cost of adding this bracket to the front panel, but to get this panel off, you'd need to take this off first, which is 2 screws on the back, and then take all the screws out. So it seems a slightly odd thing to sort of think is a hazard that someone might sort of start taking the screws out and then generate an alarm. I think this can probably produce an alarm through the app. And I mean, I can't really see it's going to be that effective, for example, if this gets hit and bumped and damaged mechanically, because it'll take quite a lot to separate this from that panel. So having some sort of tamper switching on something like this, again, it just seems rather unnecessary. Obviously, it's not a problem. It is one of the things that surprised me in terms of a pretty much lowest cost charger adding features that just aren't really essential. Similarly, the emergency stop button, that shuts it out and it goes into sort of shutdown mode. This is just a logic input. It's not like a mains cutout or anything. So if this thing was badly mechanically damaged, that wouldn't necessarily protect against mains exposure upstream of the switching. Obviously, it will shut off the charging, but that's about all it will do. This area here, there is mention in the manual of a version that's got an LCD on the front, so this is clearly the mounting points for that option. There's a connector here with 5 volts and serial interface on there, so I'm sure that's the connection for this LCD. Because down here we've got the RFID reader, and you can see the coil integrated into the PCB. This is a 522 RFID reader chip. This is all the interfacing for all the external interfaces, like the external RS485, a couple of contact closure inputs to adjust the charge rate for, I think it's the German grid connectivity function. But again, these are all opto-isolated, all conformal coated. There's a couple of connectors down here which says XDI and XDO, which is presumably some sort of expansion for some option, which obviously isn't fitted on this version. And over here we've got the networking. There's a ESP32 module. There's actually a discrete antenna with an SMA connector on there. Now there is a footprint there for what looks like a SIM card connector. but I'm not really seeing any provision for any sort of cellular modem, so I'm not quite sure where that goes. I'll have to maybe take a look and see where that goes, unless maybe there's a connector on the underside of this PCB that I've not seen yet. Wi-Fi connector with the SMA, then the little UFL connector that jumps onto the actual ESP32 module. Again, I mean, I would have thought it would be more economic to integrate the ESP chip and actually have a direct antenna connection, but obviously there's things like certifications and so on that are easier if you're using a module. And we've got the LEDs, and these are driven by an NXP LP5024 chip, which is it's not a cheap chip, but there would have been cheaper ways to do this. Maybe they're prioritising lowest development effort and cost versus production cost, at least at this stage. The other thing that's quite noticeable, actually, going back to this external interface, there seems to be lots of diodes and transorbs and protection stuff here. So again, they haven't skimped on any of that. There's actually quite a few onboard sort of status LEDs, which obviously you'd never see, but for diagnostics and maintenance. For example, over the LAN interface, you've got sort of the active and data LEDs for the Ethernet interface. The other thing I noticed is that the Ethernet LAN transformer, this is a 100 base TLAN interface. This is using the WISNet 5500, which is basically a SPI to Ethernet interface. I've used myself a lot. It's a great little chip. These LAN transformers usually include both the isolation as well as common mode filtering for EMC. They seem to have added some additional common mode filtering onto that as well. I don't know whether that was a necessity to meet EMC or whether that was just a precaution. There's also some diodes here, which I think these are probably transorbs, again protecting the Ethernet interface, but seeing as Ethernet is transformer isolated, that does seem fairly significant overkill. And on the back side of this PCB, here we've got the option for a cellular module, so that would explain that SIM card slot on the front. Not much else, although there's loads more transorb protection for the external interfaces, so they've really gone to town on external interface protection, which again, you wouldn't expect that for the a low cost product. This is definitely what you'd see, and there's really nothing to fault on this board. Very well made, lots of protection, no corners cut at all. Okay, so under here we have just a big metal plate, and we can see the main control relay here. There's a relay here for the pen fault protection. These are the two connections that go to the data connectors on the back. One thing I don't totally understand though, this plate is connected to the incoming mains earth, and there's a link across on the PCB with a high voltage marking, and then that goes down this pillar to a gas discharge surge arrestor. So we should see where that goes and what that's all about. And now taking that metal plate, we can now see the rest of it in here. So a lot of this is the power stuff. So you've got the outgoing mains connection, there's a current transformer around there. These are obviously the spaces for the three-phase version, so there's another two bus bars, another relay, and another two current transformers for the three-phase version. So the 32 amp relay dual pole, so there's just another identical relay here for the three-phase. There's a power supply module here, 15 volts, 2 amps. Seems quite a lot, but again, no harm in over-speccing your power supplies. And then tons of filtering, 3 X caps, 2 filters, and I think this is a little transformer for measuring the mains voltage, so it can do power calculations. Again, not actually necessary for a basic charger, but obviously, people generally tend to want like kilowatt hours delivered, so you need that to actually get an accurate figure. Down here, a load of Class Y noise suppression caps. Actually, I'm not seeing any sign of any transient suppression. In the UK, it's recommended that incoming mains consumer units have surge protection built in. The car's going to have transient protection on its internal input, so I don't think that's a huge deal. There might be some protection within that power supply. Here we can see the emergency stop button, and interesting, they've actually connected all 3 pins as a changeover, so I'm guessing that's so that if the switch gets damaged, it will always fail safe. Again, we can see conformal coating over all the electronics. I would have thought that's probably done with an automated dispensing system, because you don't want it over the whole board, because that's going to cause problems with connectors. But it's all the surface mount components have conformal coating on them. We've got the current transformer here for residual current fault detection, so it's detecting any imbalance, earth leakage. there. And over here, this board is for the pen fault protection. I'd suspect this is probably an option on the model number. There's an E in the model number for models with pen fault protection, which are for the UK market. And this basically provides a way of disconnecting the outgoing earth, which we'll go into that and explain a bit more about that a bit later. The actual earth connection here actually relies on this metal plate to take it from sort of over here, from the incoming earth, down to here. I will do some tests. I want to check to see if it will detect that going open circuit. I suspect it probably will. It's a problem, because at least if that does come loose and that go open circuit, at least it doesn't lose the earth without disconnecting everything else. And you can see the outgoing earth is going through this current transformer, so one of the things it's detecting is any current through here. You'll get a little bit of current because of the EMC filtering in the car, but obviously any significant current indicates some sort of fault, so again that's going to be one of the things it protects us against. So I'll do a measurement onto this to see what that actually trips at, and also see if there's any other protections in there. Down here we've got the main processor. This is a Giga device 32F427. That's the connector up to the front board. Down here we've got a few connectors. Interesting, we've got debug and SWD connectors actually populated. This one is marked temp. Now on the app there was a data value for the charging plug connector. Now on the tethered version, there's no extra wires in here going to a temperature sensor in the plug, so there clearly isn't any sensing in that plug. And in general, cars will in general have a sensor on the charge port, so that's probably not super necessary. But on the, I suspect on the untethered version, where this is populated with a socket, they probably do measure that temperature. And down here we have the connectors for the signalling. We've got CP, which is control pilot, which controls the amount of current the car's allowed to draw and it does the detection of the car. There's also PP, this is proximity pilot. This is basically a resistor to ground which tells the car the rating of the cable. So for example, if we're using an untethered cable, you might, for example, have a 16 amp cable, so that's the way of telling the car that it's not allowed to draw more than that. So there's a few specific resistor values for certain current values, so that's going to be inside this plug on the PP pin between the PP and the earth. And there's also, interestingly, a USB host connector here. A couple of things I can think that might be for. One could be for a memory stick for firmware updates, but also it may also be for a Wi-Fi dongle, because this top board, none of this is actually necessary for a basic EV charger. You've got like the LEDs on the front, all the external interfaces, and the Wi-Fi and the RFID reader. So for a basic charger, none of this is actually essential. So it may well be there's another, this board is designed to work with another lower cost version, and then there's just an option for a Wi-Fi dongle on it, which might even be, that might just come out to an external connector for a user option. Everything on this bottom board will implement the entire charger, and this is just extra goodies for the higher end versions. Down here, this is a super cap for retention of the real-time clock, which is probably a bit better than having a battery in terms of long-term lifetime. Batteries do eventually die, and sometimes a leak can cause damage, whereas a super cap, although it doesn't last as long in terms of its runtime, this sort of thing is almost always going to be permanently powered. If this thing loses its time of day, after being off for like a week or two, then that's not really a big deal. That's probably better than having a battery inside here. There's this PCB. I think this PCB is just providing additional creepage distance between the mains and this part of the PCB. I don't think there's actually anything at all on this board. It's just also on here we've got a connector marked lock and a big cap and what looks like a power driver. So non-tethered version, there's probably a mechanical lock on that connector as well to prevent it being unplugged under power. Over here we've got some BLO942 chips, which are dedicated energy metering chips. Obviously there's two missing for the other phases, but I'm a bit puzzled as to why there's two for a single phase unit. You'd only expect it to be looking at voltage and current on one phase, so I'm not really sure what that second one could be doing. There's also positions for another two potential transformers for measuring the supply voltage on a three-phase system. There's not much going on the other side. A few loads of passives. There's a TL074 op amp, which is probably to do with the measurement for the pen fault detection. A few voltage regulators. That's probably a SPI flash. Not quite sure what these two are. These are probably to do with the interfacing for the control pilot, which is a bipolar signal. So it's probably a charge pump generator. It needs to generate a negative supply for that. So that's probably a charge pump, and the others maybe some switching, bipolar switching for that. Well, looking a bit closer on some of the markings on the PCB, looks like there is some surge protection here. So these two are MOVs, which are connected from each phase to a common bus. So on the 3-phase version, there's another couple of positions. But instead of going directly to ground, they actually go through this gas discharge surge arrestor to ground. But also, for reasons I really don't understand, that ground goes through the metal plate and also through this copper on the PCB, on this top board. I'm really not sure what's going on there. If someone can suggest something, please put it in the comments. I don't really understand why they would do that. These Y caps do go directly to the incoming earth, but so these MOVs, obviously they could act as a series pair to detect phase-to-phase transients. But I'm just a bit puzzled as to why they're going through why they're going through this gas discharge arrestor to earth, but secondly, why they're passing through that other PCB as well. And down here, this little green thing, this is a thermistor, so I suspect that's sensing the temperature of the relay. There isn't any thermal coupling material, but I'm guessing that, yeah, I'm slightly puzzled as to why they use the through-hole thermistor rather than just something surface-mounted on the PCB, unless they're perhaps wanting to, I mean, there doesn't seem to be any obvious source of heat here that they want to decouple it to sort of sense air temperature, but maybe they're more interested in the air temperature than the PCB temperature for some reason. I will try and get some thermal pictures of this after it's been running at full power for a while, just to see if there's any heating issues. This is the main relay made by Hongfa, who seems to have pretty much cornered the market in power relays, certainly in the Far East. Interesting, I've not seen before, it's actually got multiple ratings. It's got a continuous carrying rating as well as making and breaking. Now, in this application, this would never normally open or close under load because the car would determine when to turn on. So that when it turns on, you know, the car will then ramp up its current. So this should never see any significant amount of current during operation, so it's quite fine to have a relay that's only rated for 10 amps making braking, but say you've got this continuous load. So I guess this is probably actually specially made for this application, so they don't carry the additional cost of having a relay that's capable of making and braking the high current, but it is capable of carrying the current for extended periods of time without getting hot, which is exactly what you want in this application. Interesting, it looks like it's got some additional auxiliary contacts, so maybe that's some feedback so that it can detect the actual state of that output relay to make sure it's in the state that the charger's telling it to be in and it hasn't got stuck contacts, for example. Okay, I got this back together. I'm interested to do a few tests. Now I've just connected up to the charge pilot pin with a resistance box so I can simulate the car being connected. Now, one thing I've tested on other chargers and found them to not be 100% compliant with the standard is, in theory, the car is supposed to connect a combination of a diode and a resistor to signal its presence to the charger, which distinguishes that from just being some random resistive load like, say, water ingress. So if I set this to 2.7k, that's a nominal value for connected but not requesting charging. So it goes to the waiting phase, but it doesn't seem to care if the diode's there or not, and so I have covered this before. It's not a huge issue, and I have a suspicion that some of the testing houses aren't actually testing that functionality because the last time I found that, the charger had supposedly been through, I think it was TUV. Yeah, I don't think it's really a huge issue. There's enough other protection that I'm not too bothered about that. And so if I now set this to 800 ohms, that's now in charge mode. That's turned the relays on and we've got power coming out. So one thing I want to check is the thresholds for the various safety protections, the residual current sensing and also the pen fault protection. A quick explanation about pen fault protection. PEN stands for protective earth and neutral, and the reason for needing this is a consequence of the way that the electrical systems on houses in the UK are typically wired. Different countries have different systems. I think there are other countries where this is also applicable, but this is why that protection is specific to the UK. It's written into the BS 7671 wiring regulations. And what it means essentially is that when the supply comes into the house, earth that goes to the house wiring is actually connected to the neutral at the point where it enters the house. This means that if there's a fault upstream in the road somewhere and the neutral becomes disconnected, the earth terminal can actually become live. Now this may sound horrific, but The secondary thing that mitigates this is called equipotential bonding, which means that all the major pieces of metalwork in the house, particularly water and gas pipes, are connected to that incoming earth. So even if that earth is actually floating at some high voltage live with respect to actual real earth, within the house, any other metal object you might be touching at the same time as you're touching earth, say for example an earthed appliance, would be at the same voltage, so you don't see any voltage across you, so there isn't a hazard. The problem is if you now have an electric car sat outside the house with its chassis connected to mains earth, which it always will be, what you then potentially have is, if you have this pen fault occurring in the street, the entire body of the car can then become live with respect to actual real earth. If someone goes up and then touches that car, they could potentially get an electric shock. So this is why this fault protection is required for EV charge points. More specifically, charge points that are mounted outdoors. This doesn't apply if the charge point is mounted inside a garage in such a way that the cable can't effectively go outside it, but that's a fairly minor case. But generally speaking, all EV charge points in the UK need pen fault protection. Most charge points sold in the UK have that built in, except there's things like the Tesla where they didn't bother implementing it, so you actually have to use an external protection box in conjunction with those. So that's really the reasoning behind it, and why you may not have come across it in other countries, because other countries sometimes have different earthing systems where this isn't an issue. For example, if the earthing to the house comes from a ground spike, then that's not an issue, because that's never going to become live. It's purely the fact that the earth is bonded to neutral, and if there's a failure upstream, then other houses will be have loads going between live and neutral. Therefore, that neutral and hence the earth can become live. Okay, so I've rigged up a simple AC current source. It's just a transformer, some series resistance, and then I'm just running a wire through the earth sensing current transformer. Pretend I've plugged in, and then just increase the current. See where that trips. 20 milliamps, which is reasonable. Once it's seen that type of fault, it seems to need a power cycle in order to reset it, which is sort of probably not too unreasonable, in that that's indicative of some fairly serious situation, but simply just unplugging and replugging the card doesn't reset that fault. I don't know if maybe there's a timeout on there, but I can see situations where that could be annoying. If there's, I mean, in the case of an earth leakage fault, that is probably fairly reasonable, but I need to check to see if it's doing any other detection, because sometimes you get transient issues, sort of mains voltage fluctuations that can trigger pen fault detection, and if it doesn't self-reset, that happens, then you think your car's charging and you suddenly find it isn't. That could be a bit annoying. And I've just checked that does also trip if the car's not connected, which of course is reasonable. It could indicate, say, cable damage or something, if you're getting current flowing through this earth when there's nothing connected. Another possible symptom of a pen fault is reduced supply voltage. So I'm just going to see what happens if we just reduce our mains voltage. There is an explicit alarm that you can set in the app to make it trip for over and under voltage, but let's just see what it does on the default settings. So it's dropping out about 120 volts, and this does self-reset once the car's disconnected. And again, when the car's not connected, again we still get that detection with the red indication, and it does self-reset. Now, another way for detecting pen faults is the voltage between neutral and earth increases. So a very quick test of that, if I'll just swap the neutral and earth connection and see what happens then. So it's starting up, and now it's gone into a fault mode. And let's just see what happens if we just lose the earth connection. Again, we're going into error mode, which is good. Okay, I've now got a new setup. I'm now running the variac through an isolating transformer and using that to inject a variable voltage between neutral and earth. So again, if the voltage between neutral and earth increases too much, then that should also trip out the pen fault detection. So let's see what happens with that. That's tripping about 35 volts, which is reasonable. Just see if that resets itself. Yeah, and that also self-resets, which So it looks like the only thing that actively latches is when you actually get excessive current through the earth connection, which would generally be a fairly bad situation. So I think it's not unreasonable that it should latch off in that state. Okay, let's just check the main residual current detection, see where that trips. I've just put a turn around the transformer so I can inject a current into it. It's tripping at 25 milliamps, that's with no car connected. Let's make it think there's a car connected. So it should trip out. Again, 25 milliamps. That stays in the air condition until we disconnect the car, then reconnect it, which is fine. And let's just check that it will trip on a DC leak. This is important because cars have rectifiers in the charger, so it is plausible that you can get earth leakage faults which have a significant DC component, and that can be a problem because if you've got an upstream AC RCD which isn't designed to cope with DC, it can actually blind that to real faults because it saturates the current sensing transformer. Yeah, so it's 5 milliamps, which is fine. Flip the polarity. Turn the car on. Again, 4.5 milliamps, which is absolutely fine. 6 milliamps is generally regarded as the maximum limit that it should have. Now, the pen for earth leakage detection doesn't trip on DC, but that's absolutely fine because all that's looking for is faults which are caused by your earth becoming live because of a pen fault and then somebody touching the car. So that's really got nothing at all to do with the rectification that's going on in the car. So there's absolutely no reason why that would ever be DC. So the fact that this only trips on AC faults down the earth is entirely fine. Okay, let's have a look at how this load balancing limiting stuff works. Got a variac connected to a transformer, just a couple of turns of wire wound around the core to generate a high current, low voltage. It's going through the current transformer, and we're just measuring the current here, so I can sort of create up to about 60 amps from this. And the scope is showing the PWM waveform. This is what the JE7072 interface uses to tell the car how much current it's allowed to draw. So the duty cycle of this PWM waveform allows the charger to tell the car to draw more or less current depending on what's available. This current is effectively what the whole house is drawing effectively. I've now set the limit to 20 amps, but when we start charging it is still telling the car that it can draw 32. Now that actually makes sense because what it's limiting is the current it's seeing through its current transformer, because you may well have a situation where you've got additional local power sources, for example solar, but all you want to do is limit what you're putting in from the grid. So all this is doing, regardless of what the actual current setting is simply, while it's exceeding the set limit, so now we've gone over 20, so it's now starting to reduce it. And all it does is simply, if it's above the limit, it just keeps reducing it, and if it's below limit, it will then gradually increase it, regardless of the absolute value of what it's telling the car it can draw. It's simply reducing and increasing to keep that limit. Because say you may well have a situation where you've got, say 10 amps coming from solar. You still want to limit the grid draw to 20 amps, so you can still charge the car at 30 amps. So that's behaving as you'd want it to. And if it just carries on being too high regardless, I think it would actually just stop charging. Okay, because we're now at the point where the charger can't do anything about it because it's still pulling 26 amps. And it's now just cut out and stop charging. And just see if it restarts after a while, once the current's come back down again. Okay, yeah, so after about a minute or so, it's actually restarted, which is what you'd want it to do. Again, it's actually just starting and just gradually increasing it from 0 because it realised it shut off before. And it will just stop increasing it once we're heading towards the limit. Now let's have a quick look at these connectors with serial data. This top one here, showing TXD, this outputs sort of periodic bursts of data. It isn't that I've just done a web connection which seems to have stopped it outputting. There's various sort of status messages, but there's also this block of data here. That data corresponds with the binary data that comes out of this TX pin. So I think that's the comms from the lower board. and say the contents of that in binary matches that hex dump. This is currently connected. This is currently connected by the over the web interface, and so I think this is basically exactly the same data. And I suspect that block of data has probably got all the charger parameters, all the voltage, current, status, etc. If I just stop that, that's now spitting out that periodic data through the serial link. And I think the RX here is the commands that the ESP is sending back to the charger board. So we see these sort of short requests and then this big burst of data. So it looks like it's probably requesting 2 different sets of data from there. And I think my guess is the data coming out of this header is for the LCD that isn't fitted. So we're just seeing odd sort of fairly regular bursts of data, sort of binary data. No obvious pattern to it, but so that's probably talking to some sort of processor on the display, so it'd be hard to figure out what that actually means without spending a lot of time on it. And there's nothing obvious coming out of this debug header on the bottom board. I think that might be perhaps JTAG. So quite surprising that one of the cheapest chargers you can buy in the UK has sort of pretty much everything that you'd want. I'm sort of looking to hook this up to the solar inverter so we get automatic charge rate control based on solar, but I think we might have to wait for the weather to get a bit sunnier before we can actually test that. If I get anything interesting out of that, I might do a video of that, but this was really just a sort of pleasant surprise I thought might be worth sharing.